We started off back in the early 90s as the carpet industry in the indoor air quality wars, as we call them. And that's where I first ran into Mike Berry and Marilyn Black, back when she was an honest professor at Georgia Tech, back before she made fame and fortune. We went through, what? We know better. We went through some really tough years there dealing with these issues. And one of the things that we found, we knew it from the very beginning because we had some data, was it wasn't a chemical issue as regards carpet. But we did find, as we went in this, that there were some issues around particulates that could be stirred up from the carpet. And one of the things that we stumbled upon real fast was that vacuum cleaners were critical to this issue. And we had had some interaction with the vacuum cleaner industry at that time, and frankly, I will tell you, it was not pleasant. Since we have a mixed company, I can't say what I was told by one of the major manufacturers of vacuum cleaners when we suggested that they do something to improve their performance. But to quote Mike Berry back in his EPA days, you can either deal with these issues yourself or somebody's going to deal with them for you. And I quoted that to this representative of the vacuum cleaner industry, and really can't repeat what I got back after that comment. So we set about to take a look at it and figure out what we could do. Now, remember, we're carpet manufacturers, and we knew nothing about vacuum cleaners except they either worked or they didn't. It was a steep learning curve. It was sometimes painful. Some of the issues that came out are the same issues that come out at my house. We have 2 people in the house and 3 vacuum cleaners. My wife has 2. I have 1. I have one that works very, very well and doesn't make a whole lot of noise. My wife refuses to use it. It absolutely cannot possibly be doing anything because it doesn't make enough noise. And that's some of the logic that we had to deal with. But we had an indoor air quality issue that we had to deal with, and we had to do it pretty quickly. We had these issues that we were concerned about. A couple of these, such as that one, had never been looked at by the vacuum cleaner industry. They're not doing a whole lot of looking at it today even. One of the slides I'll show you here in the second segment shows damage to a carpet by a cleaning machine, but there's a brand of vacuum cleaner out there today that you see advertised on TV. I won't name the name, but they make 2 models that I recall. One's purple, one's yellow. And it will absolutely destroy your carpet in very short order if you don't adjust the height exactly right. And we're working with our legal counsel now to see if we can address this somehow. This is what we're seeing. We filmed this a couple of weeks ago at Professional Testing here in Dalton to show what the average vacuum cleaner out there in commercial use is doing to the people who are operating it every day. That is a brand new unit. It was put on the market last year by one of the very largest vacuum cleaner manufacturers. And from what I would call the lower end machines, it's probably be better. There are a lot out there, the older ones that are much worse than that, and we're exposing people to those emissions. So that was one of our issues. The problem we were dealing with was political. This was another shot of it that we took with a still camera, and it doesn't really show up as well up there as it does down here on the thing, but huge emissions. And I think in Mike Berry's study at University of North Carolina, they saw some emissions up in the, where are you, Mike? 2,000 microgram range? Yes. Was that right? Yes. We got some data on that later. that industry, now here we are, a related but separate industry, trying to look at how they're doing things and change it. And it's not good enough to simply go in, do some measurements, come up with some standards. You've got to change practices. You've got to change a business model. And looking from the perspective of another industry, that's not real easy to do. But we looked at some of the tests. The traditional test that they've worked with for years looks at only what comes through the bag. They completely bypass the beater bar, the turbulence-generated dust that is kicked up around the machine. One of the things they never seemed to look at was emissions of the carbon particles from the brushes and the motors. And all of these are in the 1 and sub-1 micron ranges. These are the really nasty ones, even though they're nothing but carbon. The program that we came up with is one to look at all the dust. We put the machine in an environmental chamber. We actually vacuum carpet with it that's been impregnated with realistic dust. And we measure the dust emitted at the breathing zone. And I forget, 48 inches or 50 inches, something like that. And we do it over time. So we're measuring a real attribute of this machine, and then we set a standard. We started digging around trying to come up with, okay, what is a reasonable number here? What do we think is something that could be A, health-based, B, could be attained, and is endorsed by whoever needs to endorse it, such as EPA. Mike Berry said, pick the outdoor air quality standard, 100 micrograms per cubic meter. I will tell you that when we started off, we had about 35% of all the machines that we tested failed this test. Today, just about everything that is out there and is certified in this Carpet and Rug Institute testing and certification program, just about everything could meet a 50 microgram standard. And that's over a period of about 7 or 8 years. So it brought about tremendous change. And the amazing thing is that once the manufacturers were encouraged to try to meet this, i.e., Mr. Vacuum Cleaner Manufacturer, I, as the world's largest carpet manufacturer, we're going to write into our warranties that you got to do this, started putting some threats out there. It happened pretty quickly, and the amazing thing is that so many of these manufacturers came back to us and said, you know, this really wasn't too hard. One manufacturer actually told me that the engineering changes that they made actually reduced their manufacturing cost by about 5%. And that, in the manufacturing field, that's pretty huge. So wasn't nearly as difficult as we thought it was going to be. One of the problems that we have in this kind of testing is how do I deal with the carpet? How do I uniformly distribute a soil on a sample that A, is large enough that I can put a piece of machinery on it and do something? You know, a 6-inch square is not too difficult, but I've got to be able to get a full-size machine on here and make it operate. So how do I distribute that soil uniformly over the surface of this carpet? How do I beat it or pound it or somehow get it embedded into the surface so that it's realistic? And how can I replicate that day after day after day so that I get uniform results? It's not an easy task. We borrowed some technology from DuPont, one of our great vendors back then. They had been sitting on this for a number of years and hadn't told anybody. And we had a little research project within the IICRC several years back, and they finally fessed up, hey, we've got a method. And they handed it over. And the rest is sort of history. But basically it involves a ball mill, and with the drum and we put the test carpet around the inner circumference. We do a two-stage soil transfer process. And the way we do this, you see the gray matter here, that's not brains, that's actually nylon pellets. And we take another drum, we put the test dirt and the nylon pellets in this drum, and we tumble them. And the dirt adheres to the nylon just like it would to the nylon carpet fibers. Take out a weight amount of that, we transfer it to the test drum, and then we introduce the steel ball bearings, and we rotate this until it pounds it into the surface. And we get very, very uniform distribution. And I've got a slide a little bit later that shows how uniformly it does distribute the dirt. We take it into the test chamber, and this is a blank spot in a matrix of the test carpet. We plug the soil sample into this area, and this platen moves back and forth a period of about 4.5 feet while the vacuum cleaner is held stationary. And of course we got all the monitoring equipment up here at breathing zone height. And this is of course in a stainless steel environmental chamber. And we can measure particle mass, we can measure particle counts by size if we like to do that. We don't. So we solved that problem. Then we got around to how do we measure soil removal? Some similar challenges. The existing standard is frankly not great. And we've got a vacuum cleaner guy sitting right over here. I think he'll agree that it's not the greatest test tool in the world. First of all, ASTM F608 does not use carpet that is representative of real world. And I'll tell you a story about that. One of the very largest manufacturers of vacuum cleaners came to me in 1980 when I had first gone to work for Shaw Industries, and they wanted to buy samples of the 6 most common carpets out there in commerce, and we were more than happy to sell them. They didn't buy a whole lot, 12-foot squares. In 1995, 15 years later, they came back and wanted to buy some more. And I said, well, guys, we don't make those anymore. They're not in the marketplace. And they said, well, we've got to have some. Our carpets are worn out. They had been using the same pieces of carpet for testing for 15 years. And they had to replace them because the pile was worn away. And it never occurred to them that their test data was drifting all this time. And they didn't see anything wrong with this. So we were just absolutely appalled. That test carpet, those products are still being used today. They have to go to a small specialty carpet manufacturer who artificially produces these carpets for them. But not a single one of those is in use out there on the floors today. You can't go buy it. So it makes absolutely no sense to use this as a test substrate. Second thing is this is a gravimetric measurement. And you're measuring relatively small amounts of soil as compared to the mass of the carpet itself. So moving the samples around, handling, you lose fiber, and reproducibility is not good. A recent round robin, I understand that the replication between laboratories using the same vacuum cleaner shipped from one lab to the other was in the 30% range, which is not real good. The other thing is they're using sand as the test medium. Well, what percentage of the dirt out there in this piece of carpet is sand? Well, here in Vegas it's probably pretty high, but one particle size does not represent the universe. So anyway, we had to rethink that and come up with something else. First of all, we're not going to reuse the carpet samples. I mean, in our industry, we do have plenty of sample material. we had to have a soil mixture that was reasonably representative of the real world, and we had to have reproducibility that we thought was acceptable. So we went back to our ball mill test to soil our carpet, and it worked just absolutely wonderfully for this too. We are now moving a step beyond this, and I think you're probably the first group that has heard about this. Larry, did we mention this to the vacuum cleaner folks? I think maybe we did in the ASTM meeting, that we're ready to move forward and go from gravimetric to XRF. Okay. Well, you're the first group outside that group that's heard it. But we're going to take this one step further and go over to the X-ray fluorescence as a means of measuring soil removal on vacuum cleaners too. And you'll hear more about XRF when we talk about the carpet cleaning work. But first of all, it gives us, or lets us use a soil mixture that replicates real life. Second, it gives us incredibly uniform reproducibility. The CV on this thing is just absolutely awesome. We get pretty good correlation with the old test too, which is always a good thing to have. The other thing we've got to look at is texture change. What damage are we going to see on the carpet? And that's a relatively simple thing. We do that kind of thing every day when we're evaluating wear on our carpet samples. And it's just a reference scale with photographs of carpet worn to various stages. This is probably not too clear up there. I don't know how much you can tell about it. This is what we call a print base carpet, which is what is on the floor here. A nice short, very smooth textured cut pile carpet. And we like it because we started using it 15 years ago, and the main reason we chose it for all kinds of testing was I could steal it. It's made in the other end of the building where our technical center is, and we just go out there and whack off a bit. Actually, it's a little more complicated than that today. We have to run it through some other processing. But this sample was actually done by a cleaning machine, and in about 10 minutes, it absolutely destroyed that piece of carpet. And this is commercial carpet. Not real easy to damage it, but it did. On some of your longer pile residential carpets, the vacuum cleaner brand that I mentioned before will do that in about a month. And we're now getting complaints from consumers about that. Okay. We came up with some test methodology. We set some standards, some pass-fail. A lot of discussion about good, better, best, and all this sort of stuff, and about publishing numbers. We really don't like publishing numbers, and the reason is it gets into a numbers game. You know, mine is 0.2% better than his, but by gosh, that's a lot, and it's just really crazy. So we made it strictly pass-fail, and we went out and said, okay, guys, we're proposing this testing and certification program for vacuum cleaners, and we'd like for all you guys to take a look at the whole concept and take a look at the standards that we've established, especially the dust emission standard, and tell us what you think about it. And I think Mike Berry was the first one who got a shot at that, and of course he liked it. I don't think any of these agencies came across with any significant criticism at all. The first year, 35% failures. Today, about 90% plus are passing. We've had some comments that actually, I believe it's 2 manufacturers have told us that they were able to lower their manufacturing costs significantly by the engineering changes that they put into place. Okay, how does it work? Last year, Mike Berry did a study at the University of North Carolina, and one of the things that they were looking at was air quality in that building, and they were looking specifically at PM10 and down. They were doing an overall cleaning study, but carpet cleaning was certainly a part of that. And you can see as time went on, the ranges went down with good cleaning. We looked at some of the tested and certified vacuum cleaners versus the untested. Huge differences in airborne emissions. Huge. The machine that you saw in the animated picture there was in this range. And that was in the laboratory. I don't know that was the one that was in the building. In fact, I tried to get access to the janitorial closet out here and see what was being used in this building, but folks didn't want to let me look in there. That's one of the things that my field people always find is when they go into a problem situation, the first thing they ask for is, let's take a look in the janitorial closet. And then they try to get that guy off to the side, because what he's actually doing and what management thinks he's doing are entirely different things. Back to what Marilyn was talking about, and I think Mike mentioned it earlier this morning. Mike was talking about some of the disastrous situations he had run into with green cleaning. And I'll mention this little war story. It'll take about a minute. The University of Tennessee at Knoxville has some sort of a great environmental group there. I forget the name of the school. But they are, frankly, experts at trying to tell us how to run our business. And we sell them a lot of carpet. We get a call, the carpet in our building looks horrible. Something is wrong, and our salesperson is just going absolutely nuts because they're on her. I sent one of our folks up there, one of our better people, a young lady named Cindy Sayer, and she walked in, and the first thing she asked is, let's go take a look in your janitorial closet, because she called and said, something is wrong with this carpet. This doesn't look right, and I don't know what it is. Well, go through the motions, figure out what it is. So she goes to the janitorial closet. She's able to get the guy, the head custodian, off to the side and say, okay, what's going on here? Because I've never seen anything quite like this. And he said, well, they gave me all this green cleaning stuff to use, and they make me use it, but it doesn't work. Okay, so what are you doing? Well, I'm making up my own stuff. I'm taking this green cleaning stuff they make me use, and I'm adding a quart of 45% sulfuric acid drain cleaner. And it gets it cleaner. You're exposing everybody in the building to sulfuric acid, and he only destroyed $260,000 worth of pretty new carpet. Absolutely destroyed it. So this is what happens when products get out there that don't perform. And that's my contribution to the green cleaning issue. I shouldn't have gotten off on that, but that one is one that really sticks in my mind. Several other studies have shown the value of these vacs. The Frank Porter Graham School that Gene talked about, Charles Young School in Washington that Mike mentioned this morning. Over the period that this school was monitored, which was about 2 years, a huge renovation effort and cleaning management effort in that school. And what we saw was test scores went up. And this school was in rough shape. I've still got a picture of it, and I think, Mike, you have a copy of that picture where it's got 5 bullet holes in the front door. That tells you the side of town this was on. And they made huge changes in that school. 5 years later, the administration had changed, and it went right back where it was. Nobody emphasized cleaning, nobody was monitoring, nobody cared. It went right back in the can where it had been. So it was a total waste over the long haul. Quote from Mike Berry. Okay, another use of a measurement system or development of a measurement system put to practical use. And one of the reasons that I've been involved in the cleaning issues and the cleaning industry for, I guess, how long, Jeff? 10 years, 15 years?
Denver, 94.
Okay, 94? No, Denver was earlier than that. I got tied up with Mike Berry in the Denver study about 1990. You're right. Okay. Why? Why would a carpet manufacturer get heavily involved in the cleaning industry? We saw cleaning as or the lack of success with cleaning as a major consumer issue. Some very recent studies by the Carpet and Rug Institute with consumer surveys have shown that it's the number one issue with consumers relative to our product. We had always believed, because all the surveys had been done with the retailers over the years, that installation was the big issue. So I've got a staff of 8 guys who are out there dealing with installation issues every day. When we got around to the consumers, in every market sector, residential, multifamily residential, hospitality, healthcare, educational, there's always maintenance. I can't get it clean, I can't keep it clean, et cetera, et cetera. At Shaw, we started looking into this, and one of the things that we found was there was a huge issue with products that were available out there to accomplish this. In looking at the chemicals, we found that about 60% of everything we tested over a period of 5 years did not clean any better than water. About 60% more, not necessarily the same ones, left residues that attracted soil and made the carpet get dirty a whole lot faster. In our ignorance, and I'm kind of digressing here just a bit, but in our ignorance, what we did is we went out, we looked through the industry, we didn't find any universally accepted test methods, so we developed our own. We didn't find any standards. So we said, okay, in the absence of standard, you set a benchmark. We thought water was a pretty good benchmark. Everything should clean as well as water, and water shouldn't cause any resoiling, so it's a great benchmark. Anyway, we go back, and when we start looking at cleaning systems, we came up against the same thing, and one of which was, how do I uniformly soil it? How do I soil it uniformly enough so that I can replicate it? And then, in this case, we're dealing with much less soil, so the measurement system was a lot more difficult. Gravimetric method, when you're looking at 2 or 3 grams of soil, and I'm trying to measure fractions of that on about a 2 kilogram sample, it gets really tough. Drop off a few fibers here or there, and I got a problem. Visual evaluation, obviously the reproducibility is not great. You say, okay, let's measure it with a spectral photometer. Well, spectral photometers work great on flat surfaces, but carpet is a vertical surface. Drives them absolutely nuts. So we went around and we looked at all different kinds of technology, and finally settled in on X-ray fluorescence. And it's a fairly simple process. It is very precise. I've got not one like we're using for this type measurement. I've got a benchtop unit. They're fairly common in laboratories. They're a little more pricey. but they are nice to have. You've got your auto samplers there with 60 sample capability, and you just fill it up and feed it and go home and get your data in the morning. This is the soil that was developed, and what we're looking for is a blend of the different soil characteristics and different particle sizes. And you can see here the yttrium oxide is about 10 microns, zirconium is about 44, zinc oxide is a clumping like consistency that gives us some of the sticky component, but generally a bit larger particle size. The iron oxide is the component that gives us most of the color, and also the very small particle size, and then of course we got some potassium bromide in there to represent the water soluble component. That's how much soil it takes to soil one of these samples. Not a whole lot. And this shows an unsoiled. We started off with white carpet and decided that was not really fair, so we went to a shade of gray. This is unsoiled, and this is soil. You can see it's very uniformly soiled end to end, side to side, and it's very easy to replicate. This is the actual measurement system. Carpet is mounted on a big aluminum plating that moves back and forth, and it also shifts the measurement head. I think it's about 1.5 inches every pass, and it makes about 4 passes. I think we're taking about in a couple of minutes, and I had this thing animated, but it was kind of like watching paint dry. This thing moves at a pace of about like this. But we're taking about 1,200 measurements, so you get a lot of averaging out there. This is a commercially available handheld type device. It was developed by NASA, and they handed it off to the private sector, and we happened to be the first to pick this technology up and use it for something practical. NASA was looking at it not only to identify alloys in the space shuttle, but also to be able to look at the astronauts' boots when they step off the surface of Mars one of these days and determine, okay, do I really have my feet clean before I come in the house? Big issue, I guess, if you're up there with zero gravity and everything you track in is going to be airborne. So we took this and wanted to look at a cleaning system. It's called encapsulation cleaning. And the theory, I am told, and there are apparently 2 different thought processes here. One is to impregnate the carpet with a chemical that dries to a crystalline material. The other approach is with a polymer. I don't know how to tell the difference between the two because this is all proprietary information. But nobody seemed to have any data around this cleaning system. And here I stand as the world's largest carpet manufacturer, and I look at this thing and it's taking the industry by storm. And it puts me in a really nervous condition because if I wait and nobody comes up with data on this, let's say in 3 years, I'm going to have 100 or 200 million square yards out there on the floor being maintained with this thing. And if this thing blows up in my face, I have got a major problem. And as I asked one of the president of one of the companies that makes this juice, let's say I've got a 30-story office building in Philadelphia, and it's been maintained with your system for a couple of years, and I have a warranty on that thing, and suddenly they decide the soil buildup in this is pretty bad. How many of those floors can you buy? What do you mean? Well, they're going to sue somebody. And I don't think your company can absorb, 30 floors worth of carpet plus installation plus downtime plus everything else, can you? And he started getting real quiet then. So the position that we found ourselves in, we're going to have to take a look at this. And the reason is we've got the deep pockets and we're the guys that are going to come and see. So we started this project and started digging into it. And these were the questions that we endeavored to answer. How does it remove soil compared to hot water extraction over time? Does the soil build up in the carpet over time in successive cleanings? And what happens to the encapsulant material? Does it build up? Does it all get vacuumed out? Nobody seemed to know. The test plan looked kind of like this. I don't even know if I've got enough X's there, but the plan was to go through 30 soilings and cleaning to represent the life of this carpet. And we stopped at 19, felt like we had enough data, and I could not spend any more money. I don't want to tell you how much money we spent on this thing, but it just, it kind of got out of hand. Each of those X's that you saw up there represents 3 samples. Each one soiled, cleaned, measured, soiled, measured, cleaned, measured again, and carried back and forth. The measurements were done at Professional Testing Laboratory, which is the contract lab that's handling this testing for this seal of approval program for the CRI. So we would do the soiling at our laboratory, transport the specimens 3 blocks away. They would do the measurements. We'd bring them back. We'd do the cleaning. We'd haul them back over there. And we've got all those samples up there that you saw that had to be hauled around like this. To do that, you know, the plastic storage containers that you put clothing in or whatever and slide it up under the bed to hide it, that's what we transported them in to prevent cross-contamination. Each one of those horizontal tracks on the test plan had a different vacuum cleaner. We made some vacuum cleaner manufacturer real happy. He got a nice order on vacuum cleaners, and if anybody needs to buy a vacuum cleaner cheap, I've got some. Okay, here's what the data looks like. Yes, sir. Okay, I'm sorry. I got ahead of myself. Okay, encapsulation is a system where you take the encapsulant, let's just call it juice. That's one of my favorite terms, juice and crud. Those are my 2 generic terms for things. You take a garden sprayer, you spray it on the carpet, you work it in with a machine that has 2 cylindrical brushes that kind of contra-rotate against each other. And you go back and forth in both directions, you work it in, and supposedly it encapsulates the soil particles, and then it dries, and you vacuum it all out. Where's the data? I don't know. So we took a look at it, and the first thing we wanted to do is we said, we can't take 6 different brands through 30 cleanings. You just can't do that. You can't afford it. And so let's see how much difference there is between brands and between these 2 approaches, the crystalline versus the polymer. And let's use water as the benchmark. And you see here that through 3 soilings and cleanings, there is essentially no difference between the brands. The other thing is, there's not a whole lot of difference between the encapsulated cleaners and water. You spray water on the carpet, you get about the same result. Kind of a surprise to us. We also compared it against vacuuming only. And as you see here now this is through 19 cleanings from here on out, we get soil buildup in the carpet with vacuuming only. This is the soil level with encapsulation cleaning only. And look at the numbers here. you're getting more soil buildup with the encapsulation cleaning than you are with vacuuming only. Soil buildup with hot water extraction, which is traditionally called steam cleaning. And then we look at all three taken together, and we see it's about a factor of 2. We look at appearance, because everybody says, well, we don't know about what's left in the carpet, but it looks great, everybody loves it. Okay? But is it drifting slowly and getting dirtier and dirtier? But are we just very uniformly distributing that soil so that it all looks the same and the traffic lanes don't stand out? This would suggest that that's what's going on. This is a grayscale measurement. Actually, it was done with the spectrophotometer, and as I mentioned before, spectrophotometers don't do a great job with carpet. So we have one that's a very large aperture. It looks at the carpet from 2 meters away and looks at a spot about that big. So it averages out a lot of the difficulties. But it was converted back to what we call the standard grayscale, where 5 is unchanged and 0 is black. So as you see here, over time, the carpet gets much darker. So you say, okay, that's in the laboratory. Well, here it is. This is the actual tested specimens. This is the unsoiled control, the soiled and cleaned 5 times with hot water extraction, 5 soilings and cleanings with encapsulation, and 5 soilings with vacuuming. And you notice it's very, very uniform. We got more dirt here than we do only if we vacuumed. So what's going on here? Okay, this is what it looks like after 19 soilings and cleanings. This is the unsoiled control. This is the control after 1 soiling, just so you have an idea of how much soil goes on with each application. Vacuuming only, encapsulation, and hot water extraction. So we didn't really expect this, certainly not to this degree, but there it is. We also looked here at, and back to this, and I'm going to show you some electron microscope shots that kind of suggest what's happening here. We also looked at the encapsulating material itself. We tagged it with potassium bromide in one case, left the potassium bromide out of the soil formula for this particular track on the test plan, and looked at what happened to the encapsulating material itself, as well as the hot water extraction. Now, the funny thing that here is you would think that the hot water extraction should be much lower, but what we're doing is with the hot water extraction, you're applying a lot more material, so that's really not that surprising. Okay, that's worst case scenario that you just saw. 1 cleaning system, 19 times. What happens if I supplement that with hot water extraction, which is the way it is supposed to be used? And I soil, I clean with encapsulation, then I extract with hot water, I soil again, I clean, and then I extract. You can see soil content is going up with the encapsulation, but soil content here after the hot water extraction is remaining relatively constant, going up slightly. The difference between a 1 and a 2 is not a whole lot of difference. Then you do the same thing looking at appearance. The first was soil content, and the points are actually reversed because you're looking at Grayscale. And if you'll notice, appearance is just right up there, almost in the perfect range, because you compare this Grayscale comparison is you're looking at the test sample versus the unsoiled control. So that probably is an aberration. That probably should be about right there, because there's no such thing as perfect after 4 cleanings. What's going on there? One of the questions is, how does that detergent know the difference between encapsulating a particle of soil and encapsulating a nylon fiber? And I think the answer is it doesn't. This is the nylon fiber prior to cleaning, a couple of shots, nice and shiny, very smooth. This is what it looked like after 19 cleanings. Now remember, in case you're not familiar with electron microscopy, there's a limitation with it. And I tried very hard to get some good shots with a standard light microscope, because it shows something entirely different here. What we saw there was a very uniform coating of this polymer material on the fiber. And you could see down into it and see the soil particles embedded in this coating. The problem with the electron microscope is that to make it operate, the test subject has to be electrically conductive, and what you do is you gold plate it. Not a whole lot of gold, but just a little bit. And the problem is you can't see through the gold plating. So what you're seeing on an electron micrograph is you are just seeing protrusions above the surface, and you cannot see down into that layer of polymer at all. One of the questions that Mike Berry had asked is, okay, what happens to this stuff when you walk on it? Does it start breaking off, and do we get particles into the air, et cetera, et cetera? And we had a real surprise there. We found some places where the layer of polymer was indeed coming off, but we took one of the tested specimens and we took it back over to professional testing laboratories, and we took it into the environmental chamber where the vacuum cleaner test is done, and we ran it. And the question was, is this stuff going to come off under vigorous vacuuming and get into the air or into the vacuum cleaner? And the answer was, not really. Apparently that layer of polymer sticks pretty tightly. So that's one piece of data we didn't have, and was quite a surprise. The conclusions we came out of it with was we have a cleaning system here that, if it is supplemented with hot water extraction as it's supposed to be, it's a fine system, not a problem at all. But it's not a viable standalone system. We also found there's not a whole lot of difference between the brands, not a whole lot of difference between the encapsulant chemicals and water. Once again, we showed that XRF is certainly a viable measurement tool. Probably some other things that we can adapt this to that we haven't even looked at yet. And the other thing is I was able to show that my benchtop system can also be used for this, although it is a destructive system because I have to cut plugs out of the carpet. Anyway, it works. Questions?
Any questions? Please go to the microphone.
At your testing site, I noticed that you just tested picture-wise just upright vacuum cleaners. Did you or your company ever provide any testing on the rider vacuums or the ride-in extractors versus the uprights or the walk-behind?
Not in this. Now, within the Carpet and Rug Institute's certification program, yes.
Okay.
There are a number that have been tested.
Yep. One other question. As far as carpet manufacturers, why is it so different that from one manufacturer to the other they have different warranties as far as cleaning standards that voids the warranty?
I'm going to be honest, because they don't know any better. That is changing very fast. Yes.
On the encapsulant test, is that something recent?
This was finished less than a month ago. In fact, parts of it were just finished last week. That's why we had some extra slides here.
Steve Spivak, University of Maryland, and the CIRI Science Advisors. I didn't fully appreciate the comment about metallic coating in the standard scanning electron microscope, perhaps obscuring what you wanted to see underneath. But there are ESEMs, environmental scanning electron microscopes, that will look effectively at polymeric materials, such as fibers, without the necessity for coating. And the ESEM might give you the picture that you want to be able to see through the surface to the soil particles underneath.
Well, with some more work, we may be able to get there with a standard light microscope.
Okay.
I went back in the lab myself and tried to do this, and with about 6 people hovering over me saying, "Get out of my lab." But
Well, it was just a further suggestion. And the
it's something
ESEMs
we
are
wanna
readily
look at.
available in a number of the university laboratories and research labs.
we could see it, but we couldn't get good photographs.
Okay.
But you could see that clear coating, and you could see the soil particles embedded in it. I wish we could have gotten some good photos. Is that it?
I just want to be clear on the benefit. And if I followed your talk correctly, then what I saw was basically your summary, and that is that following up the encapsulation brought the level of cleaning back to what you would have gotten with the extraction.
Right.
What I was hoping that would be, if you're going to go through all that extra work of having a two-step process, that it would have enhanced it above it. So it would have been sort of synergistic that, that one, if the encapsulation is having an antagonistic effect on the whole carpet cleaning process, and then you follow up with extraction, you're basically just removing the antagonistic component. Did you see any of that? That's my question. Did you see that it actually greatly boosted when you followed it with an extraction?
The reason that the encapsulation system is growing in use out there is very cost effective. I've heard 5,000 square feet per hour productivity, and building managers need a less expensive way to keep their carpet looking good. And we think that you can probably go 3 to 4 encapsulation cleanings before you have to extract. I'd like to see it at 2, maybe 3 instead of 4, but we just did it every other time just for the purposes of this study. We've got some other quick and dirty work where we actually put the carpet on the floor and walked on it. And we were able to get through 3 encapsulation cleaning systems and then bring it back to a very acceptable level with hot water extraction. So it can be done.
Okay. Just specifically, did it actually boost the cleaning above what you would have seen with the hot water extraction?
No,
Okay.
did not. Is that it?
Carrie,
I knew you couldn't be quiet.
one point. An essential element of encapsulation cleaning is soil removal, and that happens after the product dries on the fiber and you come back and vacuum it. How did I guess the conclusion that I'm to draw from those graphs that you were showing, that I've seen for the first time, is that the vacuuming process did not remove the encapsulated soil. Is that correct?
Measurement was after the vacuuming.
Yes.
No, it did not.
All right, so that is an essential part of the program, assuming that the carpet ever gets vacuumed by the building user, which is a leap of faith. In our building maintenance business, we find that doesn't happen that often. But it's interesting to note that the soil just wasn't coming out. So I gather that the encapsulant was bonding the soil to the fiber. Is that correct?
That's right. Going to have to come up with some more intelligent chemicals that know just to bond to the dirt only and not anything else.
This is last question.
Last question, okay. The process, you might have covered it, I just want to just double check. The routine vacuuming and then extraction, and the extraction, at what level, how did you do a comparison between routine vacuuming and extraction compared to the encapsulant technology and extraction to see if there's a higher level of cleanliness achieved through extraction? Did I say that logically?
I'm not sure I'm following that question.
Okay, if you have a routine maintenance program where you're vacuuming,
Okay.
spotting as needed, and then at a certain point you say, okay, we need to extract.
Okay.
And that window may be a week, 2 weeks, a month, compared to you vacuum, you encapsulate once a week, you run that process, and then you do an extraction. Are you able to extract more soil from the carpet using the encapsulant technology as opposed to just using vacuuming? I'm trying to figure out what the benefit of encapsulation would be.
Cheap. Its benefit is it's cheap.
It's replacing extracting. Is it extending your extraction cycles?
But you're extending your cycle between extractions. That's its benefit.
Okay.
And if you use it that way, I think it's just fine.
But
We had to come up with some data to support that.
But your other data showed that the carpet, just on routine vacuuming, actually stayed cleaner. So where would this cycle extend? That's what I was trying to figure out.
Well, that was one of our big surprises. We did not expect that.
I just have some feedback
Bottom
on
line, I
that.
think, is vacuum, 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 vacuum.
Yeah, my name is Eddie Drone. I'm with the Clark County School District. This is a program we've been testing out in our system, and you're absolutely right. What the process is for us is daily vacuuming. We use the encapsulation as an interim maintenance program, and then extract during our break times because we don't have the downtime. So for us, it's worked pretty well, but I think you're absolutely right. You have to extract. You can't just use this as a program to maintain your carpets. It's an interim cleaning program.
The term we're trying to put on it is
We don't bond it at all. Yeah.
the term we're trying to coin for this is it's an appearance management system.
Correct.
Maybe that'll catch on.
Thank you, Gary.